You hear a squeak, you grab the blue and yellow can, and you spray. It is the universal reflex for every DIY mechanic and vehicle owner on the planet. But what if I told you that the quick fix in your hand is actually a chemical time bomb for nearly half the components under your hood? I have seen pristine suspension bushings turned into mush, electrical connectors fried, and brake systems completely compromised, all because someone thought WD-40 was a universal lubricant. It is not. It is a solvent designed to displace water, and when you introduce it to materials like specialized rubber, polycarbonate, or friction compounds, you are effectively dissolving the engineering that keeps your vehicle safe. If you have been treating this stuff like a fix-all for your car, you are likely accelerating the death of your machine without even realizing it. We are going to strip away the marketing myths and look at the chemistry of why this workshop staple is actually an engine's worst enemy in the wrong hands. If you want to protect your investment and learn which chemicals actually belong on your machine, do your wallet a favor and hit that subscribe button for Care Xpert right now. I am going to reveal the rubber melting truth that destroys your suspension geometry, why spraying this on your door latches is actually making them stickier in the long run, and the specific electrical hazard that can lead to sensor failure. We will discuss the brake death mistake that is surprisingly common among beginners, and I'll explain the one and only place where WD-40 is actually a lifesaver. Stick around because detail number 10 involves a specific interior component that will crack and peel if you use this spray as a cleaner. Number 1. Brake rotors and pads. This should go without saying, but I see it in the shop more often than you would believe. A customer has a squeaky brake caliper or a seized slide pin, and they spray the entire assembly down with WD-40. This is catastrophic. Brake pads are made of a porous friction material that acts like a sponge. The moment WD-40 hits that pad, it soaks deep into the compound, permanently contaminating it. You cannot wash it out, the pad is ruined. This leads to brake fade, where you press the pedal and the caliper slides without grabbing the rotor, significantly increasing your stopping distance. On a car, this mistake can literally cost you your life at the next intersection. If your brakes are noisy, you need high volatility brake cleaner that leaves zero residue, not an oily solvent that eliminates the friction your life depends on. But while brakes rely on friction to stop, there is another component that relies on friction to run your entire engine. Number 2, serpentine and drive belts. If your engine is making a high-pitched chirping sound from the front, never under any circumstances spray WD-40 on the belt or the pulleys. People do this to quiet the belt, and it works for about 10 seconds before making the problem 10 times worse. WD-40 is a penetrant that leaves an oily film, which reduces friction. Your serpentine belt relies entirely on grip to turn the alternator, water pump, and AC compressor. Spraying it with a lubricant causes the belt to slip, which generates massive heat due to friction burn. This heat will glaze the rubber, making it brittle, and eventually cause the belt to snap or jump off the track, leaving you stranded without power steering or a cooling system. If it squeaks, the belt is either loose or glazed and needs replacement, not a chemical bath. However, while belts get glazed, there is a rubber component underneath your car that actually dissolves when you spray it. Number 3, suspension bushings. Most people hear a clunk or squeak from their control arms or sway bar links and immediately reach for the spray to silence it. This is a massive mistake that leads to expensive suspension overhauls. Suspension bushings are typically made of natural rubber or specific synthetic compounds designed to flex. WD-40 contains petroleum distillates. When petroleum hits rubber, it causes a chemical reaction where the rubber swells, softens, and eventually turns into a gooey, tar-like mush. You aren't fixing the squeak. You are chemically dissolving the part that holds your wheels in alignment. Once that rubber softens, your handling goes vague, your tires wear unevenly, and you'll be looking at a massive bill for a press-in bushing replacement. Use a dedicated silicone spray instead, or you'll be feeling every bump in the road with a side of mechanical failure. But while suspension damage is physical, the next mistake creates a hidden electrical nightmare. Number 4, electrical connectors and sensors. Modern cars are rolling computers, and their sensors rely on incredibly precise voltage readings to manage fuel and timing. Many DIYers spray WD-40 into dirty plugs or onto battery terminals to clean them out. While it is marketed as a water displacer, the oily film it leaves behind is a magnet for dust, grit, and grime. Over time, this creates a conductive sludge between the pins that can cause a short circuit or provide false resistance readings to the ECU. This leads to phantom check engine lights, rough idling, and sensors that simply refuse to communicate. For sensitive electronics, you must use a dedicated electrical contact cleaner that evaporates completely and leaves dry pins. WD-40 stays wet, and in the world of sensitive electronics, wet means trouble. Yet the most common misuse of this can isn't under the hood, but right in your hand when you try to unlock the car. Number 5. Door locks and ignition cylinders. It is the classic fix for a sticky door lock or a stubborn ignition key. Spray some WD-40 in the hole and wiggle the key. While it provides instant gratification, you are setting yourself up for a seized lock in 6 months. WD-40 is a light lubricant that evaporates quickly, leaving behind a sticky, resin-like residue. This residue acts like glue for pocket lint, dust, and metal shavings inside the lock mechanism. Eventually, this gunk builds up inside the delicate tumblers of your lock, causing them to jam completely. I have had to drill out ignition cylinders that were cemented shut because the owner used WD-40 for years. For locks, you should only ever use dry graphite powder or a specialized PTFE-based dry lubricant. Anything that stays wet will eventually turn into a sandpaper-like paste that wears out the delicate internal components. But even worse than a stuck lock is what happens when you try to clean your lights with this stuff. Number 6. Polycarbonate headlight lenses. If you have cloudy or yellowed headlights, there is a viral hack floating around the internet that tells you to wipe them down with WD-40 to make them clear again. It works for about 48 hours. The oil fills in the micro cracks in the oxidized plastic, giving the illusion of clarity. However, the chemicals in the spray can actually soften the polycarbonate and weaken the UV coating on the plastic. More importantly, the oily residue will attract road salt, dead bugs, and grime, which the heat from the bulbs will then bake into the lens. Within a week, your headlights will be cloudier than they were before, and the plastic may even start to develop crazing or fine cracks that are impossible to sand out. The only real fix is a proper sanding and UV clear coat restoration. Spraying oil on them is just a cosmetic trick that ruins the lens permanently. But lights aren't the only plastic part at risk. The next one lives inside your air intake. Number 7. Throttle body and intake valves. If your car is idling rough, you might be tempted to spray WD-40 into the intake to clean the throttle plate or valve. Do not do this. Modern throttle bodies often have a special molybdenum coating on the butterfly valve to ensure smooth operation and a tight seal. WD-40 can strip this coating right off, ruining the calibration. Additionally, if the spray makes it past the throttle body, it can coat the mass airflow MAF sensor or the MAP sensor. These sensors heat up to measure air density, and if they are coated in oil, they will burn out or give false readings, causing your car to run rich and waste fuel. Always use a dedicated throttle body cleaner that is labeled as sensor safe to avoid a very expensive repair. Number 8. Exposed wheel bearings. Whether it's an alternator bearing or a wheel bearing on a trailer, spraying WD-40 is an act of sabotage. Bearings are packed with heavy-duty, high-temperature grease. Because WD-40 is a solvent, it is designed to break down and cut through grease. When you spray it into a bearing, it thins out the factory grease, washing it away from the ball bearings it's supposed to protect. You might think you're helping it spin more freely because the resistance drops, but you have actually stripped away the only thing preventing metal-on-metal contact at thousands of RPMs. The bearing will feel fast for a day, then it will overheat and seize, often with violent results. If a bearing is noisy, it needs to be repacked with real grease or replaced entirely. Number 9. O2 sensors. Sometimes mechanics spray penetrant on rusted O2 sensors to get them loose, which is fine, but you must never spray the sensor tip itself or get any overspray inside the exhaust pipe. WD-40 contains silicone and other compounds that, when burned, leave a silica coating on the oxygen sensor element. This is called sensor poisoning. Once an O2 sensor is poisoned, it becomes lazy and cannot accurately read the oxygen levels in your exhaust. This forces your engine into a default safety mode, killing your gas mileage and potentially clogging your catalytic converter. Use penetrating oil strictly on the threads and never let it touch the sensor tip. Number 10. Dashboard plastics and vinyl. Some people use WD-40 as a cheap interior detailer to give the dash a shine. This is a nightmare for your interior. Petroleum distillates are notorious for leaching the plasticizers out of vinyl and plastic. This leads to a dashboard that looks shiny today, but becomes brittle and cracks under the sun's heat next summer. Furthermore, the off-gassing of the solvent in a closed car can create a film on the inside of your windshield that is nearly impossible to clean off and causes massive glare at night. Use a water-based protectant with UV blockers if you want a shine that doesn't involve the slow destruction of your car's interior. The blue and yellow can has its place in the world. It is great for removing a rusty bolt on a garden gate or cleaning tar off a shovel, but it is not a mechanic in a can. Your car is a precision machine that requires specific lubricants for specific jobs. Using a solvent where you need a grease or an oil where you need a dry lubricant is the fastest way to turn a minor maintenance task into a major mechanical failure. Keep the WD-40 for the rusted hinges on your shed and use the right tool for the job under your hood. If this video saved you from a DIY disaster, hit that like button and share it with a friend who is a little too trigger happy with the spray. Keep your parts moving and your mind sharp, and I will see you in the next one.